Hey guys, here we go with probability part 2. Left off with the addition rule. Remember with the multiplication rule, you always multiply when it says and. The addition rule happens when it says or. If I want something or something else to happen. This is when we add. Just so you know, there's going to be a side note. Sometimes we also subtract, but we'll get to that. So, talking about a deck of cards, let's say I wanted to pull a 4, or, just so you know, this is the symbol for or. It looks like a U, just in case they use the symbols. If I wanted to pull a 4 or a 10. Okay. So the probability I pull a 4 out of a deck of cards, there are 4 4s out of 52. Or means add. There are 4 10s out of 52. So 8 out of 52. Easy enough. Now, here's where it comes in that sometimes you subtract, okay? These two things are mutually exclusive. Which means they cannot happen at the same time. You cannot be a 4 and a 10 at the same time. But what if I had things that could happen at the same time? What if I had done a 4 or a red card? Okay? These are not mutually exclusive. Meaning you can be a 4 and a red at the same time. So let's look at the probability here. Probability of being a 4 is still 4 out of 52. Or still means add. Or will always mean add. Okay? Red cards. There are 26 red cards in the deck out of 52. But I can't stop there. When they are not mutually exclusive, meaning they can happen at the same time, I also have to subtract. I subtract the things that are both. How many 4 red cards are there? There are 2. There's the red of hearts and the red of diamonds. So there are 2. Well, I think I said that right. The 4 of hearts and the 4 diamonds. Yeah. There are 2 red 4 cards. So I have to subtract that. The reason I have to do that, I get 28 out of 52, is because those 4 reds got counted twice. They got counted for being 4s here, and they got counted for being red cards here. It's not fair that those 2 cards get counted twice, so I have to subtract that they got counted twice. Okay, so make sure you remember that if they are mutually exclusive, meaning they can't happen at the same time, you just add. If they can happen at the same time, you still add, but you have to subtract the ones that got counted twice. Let me show you why this is. I'm just going to make up an example. Let's pretend that in our class we have, we'll say 15 people. We'll say like sushi. And let's go into this. There's a total. I'm just going to make an even number. There's a total of 25 kids in our class. Okay. 15 like sushi. I do another survey and say that 12 people like, I don't know, hot dogs. Okay. So, if I wanted to find the probability someone likes sushi, or, remember, that's the or symbol, a hot dog. The probability of liking sushi, well, there's 15 kids out of 25 kids that like sushi. Or means add. There are 12 people out of 25 that like hot dogs. Now, if I was just to add these together, 15 plus 12, I would get 27 out of 25. This is not possible. This is saying there are 27 students that like sushi or hot dogs out of 25. You can't have 27 out of 25. It's not possible. So if you ever forget to subtract, you're going to end up with situations like this sometimes. So be careful. I need to know how many people liked both sushi and hot dogs. Oh my gosh. So let's say that 10 people like both. So the correct way to do this would be 15 out of 25 plus the 12 out of 25 like hot dogs minus the 10 that like both. And that will give me 17 out of 25. That is better. It's okay, baby. Okay. So this is how the addition rule works. If they can happen at the same time, then you have to subtract. All right, sometimes you will see this in a Venn diagram. So how a Venn diagram works, and we're actually going to stick with the exact same problem, makes my life easier. Okay. Come here, baby. All right, so we'll say the circle on the left represents people who like sushi, and the circle on the right are those that like hot dogs. Now, and then we found out that 10 like both, so both goes in the middle. Out here's your total number. There were 25 kids in class, so 25 is over here. Now, it is tempting to put the total number of kids who like sushi in this one. We cannot do that. Let me go back so I remember how many like sushi. It was 15. So 15 actually goes here. Okay, 15 represents the entire sushi circle. So if 15 total like sushi and 10 of those people are here, that means 5 are here. So that the whole circle together equals 15. And then we had, what was it? 12 that like hot dogs, so 12 is actually going to represent the whole circle. If 10 of them are here, that means 2 are here. Now, there's 25 people in class, which means it is totally possible that there are some people who don't like sushi or hot dogs. They don't like either one. Let's see how many of those. If there's 5 here plus 10 here, that makes 15, plus 2 more is 17. That's only 17 kids out of 25. That means I am missing 8 kids. So there's 8 kids who don't like either one. So sometimes you see the Venn diagrams. Be careful. This number 5 is not the total that likes sushi. The whole circle is the sushi circle. Okay? All right, last thing we got to cover is independent and dependent events. We talked about this in class a little bit. Independent are things that do not affect one another. I like using a deck of cards or rolling die or something like that. So one roll of a die does not affect the next roll. One flip of a coin does not affect the next roll. When you're drawing cards, if you put it back, so with replacement, does not affect. If you're spinning a spinner, okay, one spin does not affect the next spin. So things like that are independent, where one event does not affect the other event. Okay, we also have dependent events. Okay, one event, oops, should spell it correctly, does affect the other event. Okay, this is when you draw something without replacement. So if you pull a card out of 52, sorry, I'm holding a baby while trying to do this. If you do this without replacement, so if I was to draw a card and I wanted the probability of, we'll say, a 3, and a heart. Okay, so the probability I draw a 3, there are 4 of those out of 52. And means multiply. Now I have drawn one card, one of the 3s. I don't know which one, but I drew one of them. So how many hearts are left? Assuming it wasn't the 3 of hearts. There are a total of 13 hearts, but there's now only 51 cards. Okay, so dependent means this denominator is going to change, whereas when you put the card back, it doesn't. It's always out of 52. Anytime we're talking about something coming in first, second, third, etc. Okay, whoever gets picked for first cannot get picked for second. Okay, you can't have both places. So therefore it's dependent. Whoever got chosen for first depends on who got chosen for second and third, etc. So one event does not affect another. I think that is pretty much all the stuff that is covered in these units. If you find something that I didn't cover and you want me to go over it, please let me know and I can always make another video. Hope you guys are doing good and I will see you later.